So, hi folks. Today's presentation on generating even buildings with Hypar. I'm Anthony Hauck. I'm the COO and co-founder of Hypar. A little on my background, I started work in '87 as working in architecture and took a stint through millwork contracting as well. I was the IT director for Einhorn Yaffe Prescott Architecture and Engineering, and in 2007 I joined Autodesk. I was responsible for Revit LT, Revit Server, and collaboration for Revit, and every release of Revit from about 2.10.1 through 2017 or so. I helped found the AEC Generative Design Group at Autodesk and started Project Aqaba, Project Fractal, and Project Refinery, which was recently released as Generative Design in Revit. And in 2018, I founded Hypar with Ian Keogh. So why did we found our company? We have a basic conviction that after working on buildings for 5,000 years, as we have as a species, and 50 years of trying to use computers to create architecture, that we should be able to start with something a little better than a blank sheet. Because we think that one of the issues in the industry right now is that there's a lot of expertise out there and it's still riding in people's heads. And the only way to start delivering that in some widespread fashion is to automate expertise from the source, whether it's people starting out in their careers or whether it's folks who have a bunch of projects under their belt and a lot to share. So how do we do that? What is Hypar? How have we tried to answer some of these challenges in the industry where we're still working off the equivalent of a blank sheet on our computers? You may have dealt with a bunch of different cloud services as we increasingly move to the cloud. They tend to be very targeted towards specific purposes. Hypar is a cloud platform for generating building designs from crowdsourced expertise. We are trying to provide a way for the industry to marshal and share its expertise while protecting its IP. And the way we're doing that is I'm going to take you back to math class. You may recall in math that you had these things called functions, and functions would take inputs of one kind or another in math, numeric, obviously. But in Hypar, those inputs translate into things like structural systems. And those inputs can also be the outputs from other functions, say something that generates a building envelope. So the other benefit is that with each of these functions talking to one another, they can all supply each other results that build into a complete design proposal. And the other benefit is that you can swap out those functions for different methods of creating similar things, and everything will still work together. And I'll talk a little bit about how that works under the hood. But first, I want to show you how that works in practice. So this is kind of a speeded up video that we'll dissect a little bit. So what we're doing here is selecting functions that first allow the user to pick a location on Earth and then offer some context. And here we're using actually some Mapbox feedback to find a site in Manhattan. And then we're going to create a building envelope just by sketching it right on our map. And gets us there. And now we'll start adding other functions that add their own piece to the model. So levels, and then floors, a facade, a structure. And you can see pretty quickly, you come to the point where you start to have a building proposal. And then we can do things like analyze one aspect of the building's performance. In this case, what's the view radius at a certain building height look like? And here we see if we stand in just the right spot on just the right floor, we get a view of Central Park in Manhattan. So what I'm going to do here is switch over to a live demo and dive into a similar workflow so we can kind of take that apart and see what's going on. So this is our CanBIM tower, same place in Manhattan. And each of these is a function. And there's a library of functions that you can access that contribute various things to the model. But each of those functions also has its own settings. So if we do something like we can make the building taller, for example, we can change our setback intervals on how often those happen. And what's happening here is that we're creating a new envelope, and every one of the dependent functions down here, which makes levels and floors and structure, etc., is now working off the new building information. So what we can do also is when we have things like sample range checked off, we can also look at a bunch of different options that have been automatically generated, because one of the benefits of having a cloud system is you're not limited to a single CPU. So what we do is we distribute calculation of options across multiple CPUs. So calculating 20 different options is as fast as calculating one because they're distributed. So we could even, switch off to something maybe dramatically different. Let's see if we can find one of the ones across sample range. Let's try this one with four tiers, and we'll let that regenerate. So these kind of options are available in every one of the functions. So you can change your level heights, for example, here. You can change your floors by levels, and you can change your structure. And let's look at each of those in isolation for a minute, so you can see how each one contributes to the model. So we can isolate each of the functions output like this. So here, we're not even seeing the location. Now we'll just see the envelope regenerated, and here are the levels and the floors. There's our relatively simple structure. You can see that we just have axis intervals that we can set. Now, all of these things that you're seeing here, these are all available to you on Hypar right now. And if you have a mind to contribute, and we'll go into more detail about that, one thing you can do with a lot of the functions that are on Hypar is you can go to About, and often you'll see a source code link. So if you are C# code inclined, you can open another window here, and this will take you right to the source code of the function that you were just using. Now, all of this is open source. None of it is directly tied to the Hypar platform. You can use this stuff locally if you like, and I'll go into more detail about some of that when we talk about what's behind all of this functionality. So, continuing on, we can do things like select different locations, and we can type in, we can move this entire building to Tokyo if we wanted to, for example. So you have a worldwide access. Now, I will say that we're drawing our information from Mapbox. Your mileage may vary on the validity of the information that comes out of it, depending on where you are. We find some really good data in large cities around the world. When you start to get outside the urban areas, or even sometimes in areas of secondary cities, the building heights get a little shaky. So just a word to the wise on that. Going back to what's underneath here, I'm going to go back to the presentation. So the reason all these functions get to talk to one another and pass off information is, let's say, for example, I take out levels. Everything is going to start to complain that it's using levels and it needs them, and we can always add those back in. But the reason that all this stuff can talk to one another is there's a library underneath which represents the building elements. And it's things like site and level and envelope and all the stuff you see me play with here. This is also an open source library. It is also not tied to the Hypar platform. We have seen people take this library and use it as the basis for operations in Dynamo under Grasshopper, and we'll talk a little bit about that. But you can take this library and extend it if you're a C# developer and use it to your heart's content. If you have no connection to development at all, you can go to Hypar and use all the functions that people put on there to create your models. And when you finish, I save some time here by exporting, so it takes about 45 seconds. But one of the things I did was export this model as an IFC. And we'll let BIMvision open this up. And here we've got the whole area, including our building, which is hidden down one of these next to one of these tall guys here. Okay, so going back to the presentation, we've got a lot of ways to help you on Hypar. We've got a getting started guide that will let you also extend this data model. So one of the issues with a lot of data models in AEC is that they come very rigidly categorized. So you end up having to categorize something that the developers didn't conceive of. Let's say, on the outside, you have something like an umbrella stand or an operating room or a patient room that you want to represent. And of course, large pieces of commercial software can't think of every single thing you want to represent. So one of the things we did with the Elements library is we made it extensible. So if you add something to the Hypar Elements library, you don't have to talk to us about it. We never have to know you even exist, but you can actually make a first-class element that the platform will recognize, or the rest of Hypar will recognize if you're using it just on your desktop. If you're interested in how that works and you want to develop it yourself, there's a GitHub repo called under Hypar-IO schemas. And these are all individual schemas that describe things like levels, level perimeters, mullions, the building envelope, etc. And you can see how that's done. So there are 3 ways to put something on Hypar to add your own functionality. If you want to take advantage of working with the functions that are on there together with something you develop. If you're working in C#, you can do that with a command line. And here's a quick video on me making a function called CanBin demo yesterday. So I type in Hypar new, and it goes through and it creates a project that we'll look at in a second. And then it creates a solution, and then it archives it and uploads it to Hypar. Now, in this case, one of the important things to understand is if you put something on the platform, we don't see any of the source code. But if you're using Elements, your function can talk to any other function that also uses Elements. So what we hear a lot from firms is they would like to collaborate on projects like this, but they don't want to share their IP directly. So this is a way for you to put something on a shared platform that does something that your firm knows how to do and combine it with something that another firm knows how to do. And neither of you shared your IP, you're just communicating with a common data standard. So if I go back to an empty workflow, we'll look for something called CanBin demo. So the default function, if you try this, is just something that essentially makes a big pizza box. And you can play with things like length and width. So it's in a few seconds, you can actually have a functioning web application that is instantly distributed worldwide if you make it public. This particular one, I believe I've made public this morning, so you can try it out. But this is really meant as a skeleton for a more elaborate program that you can create inside your favorite code editor. In this case, I'm using Visual Studio, but here's something, the height is fixed. So usually if I'm showing people how to use this, we go through the exercise of how to add a height input. But you can see there's a volume calculated, and a rectangle is made, and we make a mass, and it's got the input length and height. And that leads to this. So this is fairly simple to begin with. If you have some experience with development, you can try it. But if you're not a C# person, there are some alternatives for you. So one of the things that we've added recently is Grasshopper compatibility. So here, Andrew Human, who's on our staff, is working on a Grasshopper script that generates a mesh skin for a building, and then he'll add some rainbow colors, and you'll see it flash in the upper left corner as he adds. And then he takes the Grasshopper script and he adds a new function, and he just drags and drops it right into Hypar, and give it a few seconds processing time, and we'll actually wrap that graph up into a functioning Hypar entry. And then the nice part about this is that now it will work with all the other Hypar functions. So here, envelope by sketch, written in C#, is now working with this Hypar model dependencies thing that Andrew's created to add this rainbow facade onto that building envelope. So your third alternative for putting something up on Hypar is using Excel. So by naming cells in Excel by inputs or outputs, we can automatically translate this into the Hypar interface. And I think I probably don't have to outline for this audience the nightmare of the emailed spreadsheet that gets out of date and numbers change, and you're making business decisions on the basis of it, and maybe you make the wrong one. This is another way to distribute just a raw spreadsheet around a company so that people can use a canonical copy of it. And you can make some adjustments to the spreadsheet and how you want the interface to work on the way in. And what's coming, hopefully at the end of this week, is an ability to hook this directly into outputs of the rest of the model. So if you wanted to feed in your square footage or square meterage from your building and get outputs like this, your cost basis, your loan value, et cetera, and what your projected income would be, you could make a spreadsheet like this. And the reason we did that is we know that there's a big chunk of expertise in the AEC industry that's residing in spreadsheets spread around firms, and especially engineering and real estate. You'll see that a lot, often in construction. So overall, what are we trying to solve here? We saw a lot of problems in the industry that we wanted to address. One of the main ones is this difficulty in translating automated prototypes into practice. Early on in Hypar's life, I had a meeting with an executive of a large architecture company, and we were talking about some fairly primitive stuff on Hypar. And he was asserting that, they're doing very sophisticated things in their firm. And I said, of course you are. How's the internal distribution of that going? And, my friend got a little hangdog about it, because the wall that we see firms hit over and over again is they produce this great, some great automated practice out of their research group. And then they have a long, hard slog to get that distributed around the firm. And so we wanted to give out a way for people to upload something and instantly distribute it around the firm or around the world if they wanted to. So we also see this difficulty in scaling to projects, that it's hard to complete development, it's hard to distribute them, as I mentioned, and it's hard to maintain them, because once something's out on everybody's desktop, then you have to redistribute it to everybody's desktop if there's an update or a bug fix. And here, it's one upload. Everybody instantly gets everything that they need. Also, this lack of common data representation. Of course, we've got all kinds of standards out there, But there's very few lightweight standards that enable you to do web development. There's BHome from Borough Happold, and there's Hypar Elements. All of these are great. We wanted to make something that was free, extensible for everybody, and has the capability for everybody to contribute to start making a shared cross-industry project on trying to represent the built environment in a way that we can all help each other's success and build on each other's knowledge. We also saw that it was very hard to extend the existing data model, so we made this extensible. And one problem that's a little more subtle, and we wanted to make sure we started to address, are things like different firms all concentrating on 90% of their effort into what are essentially commodity technology stacks. So it used to be that everyone would make, for example, a stadium bowl layout software, typically in Grasshopper or Dynamo. And lately, in the last couple of years, we've seen a lot of different firms all working on their very own web viewers, or all working on their own location pickers. And so we're trying to either solicit or create a lot of that basic infrastructure for folks, so you can actually concentrate on what the core expertise you're trying to produce, spend 100% of the effort on that, instead of 90% of your effort on the infrastructure and another 10% actually supporting your idea. So for one thing, we wanted to see firms, for example, stop concentrating on how to learn AWS and keep up with changes in AWS, because that's also a full-time job, and everybody on this webinar has a full-time job already. They don't need a second one. So, when we saw firms investing like that, we realized they were competing kind of on commodity technology rather than a differentiator. We really wanted people to be able to concentrate on their differentiating idea. As I addressed, this difficulty in technical collaboration, where people are trying to collaborate, so they're sending whole Grasshopper scripts to one another, or Dynamo scripts. And so this way, without sharing IP, people can still communicate and build on each other's successes. And so we wanted to basically give a platform for everyone to be able to work together, but still stay competitive with one another on the things that count. So if you want to go deeper on this, we have a bunch of resources, and I think I'll have time to show you one more interesting demo involving Revit. So as I said, there's the Elements library. There's instructions on making Hypar Functions. There's more detail in the Elements library. You go into each element in there. Instructions on making Grasshopper scripts. There is a Grasshopper package up on Food for Rhino called Hypar Elements that will supply you a bunch of pink outlined nodes that you can use to integrate with Hypar. We have instructions on starting with Excel. There is a Hypar Dynamo package on the package manager if you're a Dynamo user. And there is a sample Dynamo script to show you how to extract information from Revit. So I'm going to pop into the live demo again to show you how that works, or at least the results of it. So those of you who are familiar with Revit will probably recognize this guy. This is the architectural house that comes with Revit as some of the default content that you can use. And so what we've done here is we've used a Dynamo graph to extract walls and floors out of Revit. And we'll talk a little bit more about that in a second. And then we've dropped it in here, and I'll just do this. I'll do it live in a second. Let me show you some other results. So what we've got here is 3 functions. One, this JSON to model that I'll explain in a moment. 1, panels from walls, and 1, prefabricated panels. So if I isolate each of these in turn, you'll see that we've taken the walls and floors we've extracted from Revit, and we isolate that. And now we've panelized all the walls here according to the length and corner length in the function. And then if we isolate prefabricated panels, we'll see that we also have framing inside every one of those panels. So this is how we intend the platform to work, where people can just kind of add on new functionality whenever they need it onto existing functionality to do something that in this case, it's even more detailed than just merely panelizing the walls. So if you're interested in this kind of thing and interacting with data you pull out of Revit, there is a repository on GitHub, and we've got all this kind of information, and I'm going to use some of it live now so you can see it. So from my local copy of that repository, we've got these JSON to models, and we've actually got the Revit 2020 models that actually exist on the GitHub repo. And then we've got the extracted JSON versions and the Dynamo graph here that created the exports, the exported JSONs that you see. So if we go back to our workflow and we change up our JSON, let's switch over to the commercial model instead of residential. And so that gets uploaded. And now, like you see in other Hypar functions, everything else is responding to that change by producing panelization and framing. And we give it a few seconds because we've only got the prefabricated panels isolated. Or in fact, this one's done, so maybe we can isolate that one. You can see that the commercial model has been panelized, and in its raw form, it looks like this. And then if we go into prefabricated panels, if it's done calculating, there we go. We've got the panels again on a completely different building. And so you can do this yourself with the Dynamo graph, if that's the kind of thing you roll on, to try this out. And so this repository, I'll just look at my local copy. It's probably a little easier to see. Has source data for a number of Hypar functions. So we can go to, for example, DXF to floor. So it's what you imagine, taking a DXF file and turning it into a floor outline or a site. A sample Excel spreadsheet for you if you want to try out the Excel to Hypar functionality, some extra JSON files from other Hypar functions that you can try or read, and the JSON to model. And then program by CSV is actually a building program that you can use to generate a space program in the function of the same name. So going back here to our presentation. This is the Dynamo file that you will find to extract the walls and floors. So, feel free to take a copy of this and play with that. And as I say, we've got the function data, and then, we've got a few things that we're working on next. So, as I mentioned, the next thing we'll probably have out, hopefully, like I say, by Friday, maybe next week, we'll have a way to reference elements into your Excel spreadsheet. And so, for example, if you have a bunch of floors, they have a certain area on each floor, so you could aggregate the area and figure out your cost or whatever it is you need to figure out off your floor area. We're working on desktop software integration. It's Revit. So what we're doing there is we're actually going to have a real-time interchange with Revit on the desktop. If you're generating stuff and want to bring it into Revit or send stuff from Revit back up to a generative process on Hypar. We're looking at Revit family interoperability. So that'll be done probably in about 2 or 3 months, where we start bringing in Revit content. So for things like piping systems or furniture and that kind of thing, if you want to bring that in, we have in process right now an optimization library. So we're working on one project around space planning that works on using an optimization module, and we'll probably have a few of those. Python compatibility, which we have working behind the scenes, but we haven't exposed yet because we're still making sure it's stable. Some better model visualization for things like element selection, data visualization of results, some better model element interaction. We can try some of that live because I've got a couple of minutes left. A platform API, if somebody wanted to build a website right on top of this functionality and never mention the word Hypar. Being able to finally control the distribution of your functions. We can talk a little bit about that, and subscription accounts and corporate account management. So let's just, since we've got a couple of minutes, let's look at a couple of these things. So going back to our original tower way back here, one of the things we can do with our tower is we can make this quite a bit smaller by going into envelope by sketch and editing our polygons. So we can do, take out a couple of these, take out a node and do this and fix it there, and then just update it. And again, all the other functions will update. So there are that are already on Hypar that let you do things like put in a new perimeter, or as I promised kind of early on as this is finishing up, we can even swap out functions. So we can do something like, if we want a different way to make an envelope, we could do something like envelope by centerline, and then we'll get an error that multiple functions are producing envelopes. So let's get rid of that one. And then let's draw a new polyline, say from here to here, and let it go. So this is kind of the power of having an open system. You could contribute your very own way of making a building envelope into this, and then everything else will respond to whatever it is you put. And I think I've just put my my building in the middle of the street, so there'll be some complaints about that. But anyway. Okay, and that about wraps it up here. So I'm gonna open it up to questions and see if Dave, if you're still there, are there any questions on the queue?
I'm still with you. So far, I have one question. I also tabled one of my own in case we ended up with extra time. The question is, what is Hypar's business model? Are you a not-for-profit?
We are not a not-for-profit. We are a for-profit company. Our business model will be subscription. There will always be a free tier. Everything on Hypar is free right now. Toward the end of this month, we'll be turning on subscription. There'll be a couple of levels. It'll start out as $19 a month, and then I believe the second tier is going to end up being around $39. There'll be various types of functionality attached to each tier. On the free tier, essentially the limit will be how much computation you can do in a month, and we're still kind of playing with those levels, but we want to make sure that people can do some useful stuff even on the free tier. There may be some functions that aren't available on the free tier that are reserved for subscription folks. And then moving beyond kind of individual subscriptions, we'll also have a couple of corporate plans where people can buy blocks of floating users, because I'm not too keen on not being able to float users in the corporate environment, having been an IT director. And then an all-you-can-eat option for an entire corporation to sign on freely. So essentially, about 3 tiers of individual user subscription, free $19 and $39, and then two ways to buy it at the corporate level. Other questions?
Exactly. Don't have any new ones, but I did come up with one of my own. It's a little bit related, and that's about the permissions model. Because it's in the cloud, I find this even with our own software. Sometimes you want to be able to create your data and control who can make changes to that data and who you can give access to look at the data. So do you want to describe your permissions model there? Can you invite somebody who's not a subscriber to come and look at your project information? Is it possible to lock down parts of the data so they can't change it? That sort of thing.
I'm glad you asked, and it's not that refined yet, but let's talk about sharing a little bit. let's bring up this. So let's say after this seminar, you try all this out and you think you got something really cool and you want to share with your colleagues. There is a share button down here. And you can either send out individual access to email addresses, or you can send just a link to anybody you like. When the person gets this, if they're not the owner of the workflow that you sent out, and this whole thing is a workflow, they will be told that they can make a copy of it and work on it. One of the things that we actually have probably about 4 months out is real-time collaboration between folks. And I think we're going to have to deal with the permissions model right then, Dave, because obviously, everybody's stepping on the same function would probably be a problem. But yeah, right now you're kind of sharing wholesale. Anything, if you end up trying this out from the Grasshopper, Excel, or C# side development, everything you upload is automatically private, meaning that only you can see it. And right now, the dichotomy is it's private or entirely public. But if you talk to us, we have behind the scenes a way to create what's called a team. And for example, if you work for a large 3-letter design firm and you would like your functions to only be visible to your colleagues at the firm, we can make a team that's just focused on your domain, or a team that's focused on the list of folks you would like to have access to it. And that's what part of the corporate account management thing that we have under development is so that we don't have to do it, you can, because we understand that that kind of individual access is going to be important to control for folks.
Hey, thanks for that. And we still have more times, but I don't have any more questions. So I dreamed up another one on my own.
Okay.
As a cloud service provider ourselves, we're occasionally asked about high security projects. And in many cases, especially government projects, where they don't want the data to live in another country. They want it to live in Canada.
Right.
Can you talk about your infrastructure there and whether it's Canadian, and you can give that sort of reassurance?
So underneath this, we use AWS. And if there was a data sovereignty issue, we would be looking to try to spin up against an AWS facility in the target country. One of the things we did in designing the whole platform is also make it somewhat loosely coupled to the service provider. So if there was a very good reason, we could actually also spin up a Hypar platform onto Azure, for example, or even GCP. It would have to be a very good reason to do that. But it is possible. We sort of designed the whole system with that idea. And actually, you're giving me an opportunity to address one more thought here about that. Much of what you guys have seen today is open source. So you can go get the Elements library. You can get a lot of these functions, like if you wanted to find out how we did the facade, you could go out to that and pull that code and use it for your own projects on Hypar or off Hypar. We don't really care. But one thing you'll see that is not open source is the platform itself. And there are certainly business models like Discuss is a good example, which is a company that provides forums for websites, and their entire stack is open source. You can spin up your own Discuss on your own server. They don't mind. Their business is, but you don't have to. And we kind of constantly, meaning like about every quarter, debate on whether we should open source the entire Hypar platform for the industry. The reason we have not is one of the things we're afraid of is that we will be contributing to a problem we're trying to solve. If we do that, we're kind of worried that people will take the Hypar platform, put it behind their firewall, make their own ecosystem, and never ever share. So for now, we're reserving the Hypar platform as a centralized place because what we see is too many walled gardens around the industry and not enough sharing. And by contrast, one of the one of the strategic approaches that we're trying to emulate is what happens in the software world. For those of you, have any kind of consciousness of what goes on, somebody like Facebook will release React, which is an entire UI framework, and they'll give it away. And, everybody's probably lost count of how many tools that Google has released for free that people can use to keep building on each other's success to make a richer, more varied ecosystem. And that's why the software world moves so quickly, because there's an entire industry that's cross-pollinating constantly to create more value for everyone. And we're trying to provide the means to do that. One of the incentives on the contributor side is contributors who put things on the platform. Naturally, they can keep them private to their firms and use it for a competitive advantage. But we're also going to provide the means for people to charge for use of something they post on Hypar. So if you want to, charge access per week or month or per use or something, you set a price and we'll take 30% of that. So we're also going to try to engender a marketplace so firms can have a secondary passive source of income from expertise that they're using in their production, but they feel comfortable also charging other folks to use. So the interest we've had across the industry has been, rather wide because we've got, folks from construction are interested in sort of just making their means and methods consistent across their whole companies. But we also see, interest from building product manufacturers who want to provide some kind of configurator for folks to use their products and essentially as a sales tool so that they can quickly arrive to a design and a sale using their products. So you can imagine how you could apply that even to the design world where you're quickly producing designs and being able to kind of sell that decision to a client.
Thanks, Anthony. No new questions, so I dreamed up another one while you were talking about open source.
Yeah.
My thoughts, putting my Building Smart hat on, I did see a reference to an IFC file in there. Can you describe your support for Building Smart standards, importing or exporting IFC files or property sets? Give us an overview.
Yeah, you can do both. Of course, you're always limited by the thing that's reading your IFC file. And we've run into that with Revit and a couple other readers. It seems like, we can't quite always get all topographical context out, but we are IFC 4 compliant. And we try to, let's go over here. Sorry to make everybody dizzy. I'm just zipping around the model. But we can even do that. We might have just enough time to do this live. Let's pick another, a different model. Let's go into, I don't know. I'll do another demo for a layout, and let's see if we can export this one. So there's 3 formats we can currently export. One of the reasons we're working on Revit compatibility is to make this also these kind of results go directly into Revit, but right now you can hit IFC. This takes about 45 seconds or so to spin up, so I'll just banter over it, I guess. But in any case, we try to remain IFC 4 compliant with things that do not fit into the IFC universe. We use the IFC proxy object, and I imagine that as we get our Revit compatibility pulled together, we'll end up doing some things either in the generic category or in the direct shape rendering inside Revit. So, and one of the things that also people ask, connected to your question, Dave, is why not use IFC as the standard? I will say we really tried to use IFC as our data standard. It's a data standard that is largely designed for interoperability and archival capabilities. It's not very technically astute when it comes to using it for web handling and data transfer on the web. So that's one of the reasons we developed Elements, but we looked very closely at IFC and Revit's data structure and try to kind of make a happy medium in taking advantages from both, but also making it open-ended for folks and usable outside the context of Hypar if people find it helpful. So we're trying to stay compatible with kind of popular standards. And the nice thing about the JSON, and maybe we can pop into there real quick in our last couple of minutes. If we go over to our schemas, the nice thing about JSON renderings of things is that they're kind of human readable, so you can actually sort of see that levels have elevations in them. And there's a bunch of kind of gobbledygook up here that is more for computers than people. But all this stuff is kind of written in a way that is open-ended as far as maintainability over time, because it's an open standard, because you can read it. It's the kind of thing that any competent developer would be able to look at and understand how it's working. And you could even make your own parser for this kind of thing.